JavaScript supports a variety of data types, which can be broadly categorized into primitive and complex types. Primitive data types include number, BigInt, string, Boolean, undefined, null, and symbol. The number type represents both integers and floating point numbers. Using the double precision 64-bit binary format IEEE 754. It supports a wide range of values, including special ones like infinity, negative infinity, and none, which stands for not a number. For example, you can declare a number using let num equals 42, or a floating point number with let float equals 3.14. Single quote dot. BigInt, introduced in ES 2020, allows you to work with integers of arbitrary precision. You can create a BigInt by appending an n to the end of an integer or using the BigInt constructor, such as const big number equals 9,7,254,740,991 n. Single quote. However, BigInt cannot be used with methods from the math object. Strings represent textual data and are enclosed in single quotes, double quotes, or backticks for template literals. They are immutable, meaning once created, they cannot be modified. For instance, you can declare a string with let str equals hello, or use a template literal like let template equals backquote value $num backquote single quote dot. The Boolean type represents logical entities with two possible values, true or false. These are commonly used in conditional statements and logical operations. For example, let is active equals true. Single quote dot. Undefined is a type that represents a variable that has been declared but not assigned a value. It is also the default value for function parameters that are not provided. For example, let undefined var single quote dot null, on the other hand, represents the intentional absence of any object value. Interestingly, the type of operator for null returns object, which is considered a bug in JavaScript. An example would be let empty value equals null. Single quote dot. Symbol, introduced in ES 2015 or S6, creates unique and immutable identifiers. These are often used as property keys to avoid name collisions. For instance, const unique key equals symbol. Description, single quote dot. Moving on to complex or reference data types. We have objects, arrays, functions, date, regexp, and map. Objects are collections of key-value pairs and serve as the fundamental building block of JavaScript. You can create an object using object literals, constructors, or object create. For example, let person equals name, John, age, 30, single quote dot. Arrays are ordered collections of values and are essentially specialized objects. They are zero-indexed and can contain mixed types, such as let I equals 1, 2, true, key, value, single quote dot. Functions are first-class objects in JavaScript, meaning they can be passed around like any other value. They can also have properties and methods. For example, function greet, name, return backquote hello, $name, backquote, closing curly bracket single quote dot. The date object is built into JavaScript for handling date and time operations. For instance, let today equals new date, single quote dot. Regular expressions, or regexp, are objects used for pattern matching. An example would be, let pattern equals d plus per gram. Single quote dot. Lastly, the map object, introduced in ES 2015, is a collection of key-value pairs where keys can be of any data type. This makes it a versatile tool for managing data. For example, let map equals new map. Single quote dot. In summary, JavaScript's data types provide a robust framework for handling various kinds of data, from simple numbers and strings to complex objects and functions. Understanding these types is fundamental to mastering JavaScript programming. Let's dive into some key JavaScript concepts in the evolution of ECMAScript standards. First, we have the map object, introduced in ES 2015, which allows us to store key-value pairs. For example, we can create a map using let map equals new map. Key 1 foot, value 1 foot, key 2 feet, value 2 feet, single quote. Next, we have the set object, also introduced in ES 2015, which is a collection of unique values. For instance, let set equals new set. 1, 2, 3, 3, 4 will store only the unique values 1, 2, 3, and 4. Moving on, we have weak map and weak set, which are similar to map and set but use weak references. Keys in a weak map must be objects, and they allow garbage collection of keys, making them useful for memory management. For example, let weak map equals new weak map creates a weak map instance. Now, let's discuss type conversion. Explicit type conversion, also known as typecasting, involves manually converting one data type to another using methods like number, single quote, string, single quote, or Boolean, single quote. For example, let num equals number 42 converts the string 42 into a number. On the other hand, implicit type coercion happens automatically during operations between different types. For instance, 5 plus 2 results in the string 52, while 5, 2 feet results in the number 3. Next, let's explore the evolution of ECMAScript standards. ECMAScript 1, released in 1997, was the first official version, introducing basic language features. ECMAScript 2 followed in 1998 with minor changes and alignment with the ISO standard. ECMAScript 3, released in 1999, added support for regular expressions and try-catch exception handling, becoming the widely supported baseline for years. ECMAScript 4 was abandoned due to disagreements about its complexity. In 2009, ECMAScript 5 introduced significant features like strict mode, JSON support, array methods such as for each, map, and filter, and object methods like object, create, and object, define property. It also added getter and setter accesses. ECMAScript 5.1, released in 2011, made editorial changes and aligned further with the ISO standard. The major update came with ECMAScript 2015, also known as ES6, which introduced classes, modules, arrow functions, template literals, destructuring assignment, default parameters, rest and spread operators, let and const declarations, promises for asynchronous operations, and new data structures like map, set, weak map, and weak set. It also added symbols, iterators, generators, and features like proxy and reflect. Subsequent updates brought incremental improvements. ECMAScript 2016 added array, prototype, includes, and the exponentiation operator. ECMAScript 2017 introduced async, await functions. object, entries, single quote, object, values, single quote, string padding methods, and trailing commas in function parameter lists. ECMAScript 2018 brought rest and spread properties for objects. Asynchronous iteration, promise, finally, single quote, and regular expression improvements. Finally, ECMAScript 2019 added array, prototype, flat, single quote, array, prototype, flat map, single quote, and object, from entries, single quote. These updates reflect the continuous evolution of JavaScript to meet the needs of modern developers. In this presentation, we will explore key advancements in JavaScript and its ECMAScript standards over the years. Starting with string, prototype, trim start, and trim end. These methods allow developers to remove white space from the beginning or end of strings. Additionally, the optional catch binding feature simplifies error handling, while the function, prototype, toString revision ensures more consistent function string representations. Moving to ECMAScript 2020, or S11, we see the introduction of the BigInt primitive type for handling large integers, dynamic import for modular code loading, and the nullish coalescing operator, which provides a more precise way to handle null or undefined values. Optional chaining simplifies accessing nested object properties. Promise, all settled, enhances promise handling, and the global this object offers a universal way to access the global scope. In ECMAScript 2021, or S12, new features include string, prototype, replace all, for replacing all occurrences of a substring, promise.any, for resolving the first successful promise, and logical assignment operators like and equals, and, equals. Numeric separators improve code readability, and weak refs and finalizers provide advanced memory management capabilities. ECMAScript 2022, or S13, introduced class fields and private methods, enabling more robust object-oriented programming. Top-level await simplifies asynchronous code in modules, while error cause provides better error debugging. Array.prototype.at offers a cleaner way to access array elements. Object has own, improves property checks, and regexp match indices enhance regular expression functionality. In ECMAScript 2023, or S14, new array methods like findLast and findLastIndex were added, along with non-mutating methods such as toReversed and toSorted. Hashbang grammar allows scripts to specify their interpreter, and symbols can now be used as weak map keys. Looking ahead to ECMAScript 2024, or S15, we anticipate the array, group by, method, the temporal API for standardized date and time handling, further regexp improvements, and import assertions for module imports. Next, we delve into type checking in JavaScript. The type of operator returns a string indicating the type of a value, though it has limitations, such as returning object for arrays and null. The instance of operator checks if an object is an instance of a specific constructor. For more reliable type checking, object, prototype, toString, call, can be used, and array, is array, specifically checks for arrays. Finally, we discuss the evolution of JavaScript's type systems. Dynamic typing remains a core feature, allowing variables to change types during execution. Type coercion has been standardized to ensure predictable behavior. Optional type systems, such as TypeScript by Microsoft and Flow by Facebook, provide static type checking, while JSDOC annotations enable type checking through comments. This comprehensive overview highlights the core data types in JavaScript and the evolution of ECMAScript standards that have shaped the language into what it is today.